Assalamu alaikum wa rahmatullahi wa barakatuh. We'll continue with chapter 5, lecture 2. We are going to cover here structural model. Structural model actually of software, it will display the organization of a system in terms of the component that make up the system and the relation between them. It could come in two different forms. Static models, which show the structure of the system design, and dynamic model, which show the organization of the system when it is executing. As we did explain in the previous lecture, we said we are going to cover in this chapter 4 different models. Context diagram, that one it's really a static. Interaction diagram, context diagram or the context model, which it is the context diagram. Then we went to the interaction models and we cover the use case and the sequence diagram. Today we are going to cover structure model. Structure model, which is really represented like in the class diagram. And then in the next lecture we finish the chapter by having the behavioral diagram, which it is the state transition diagram, and then the last couple of slides we going to talk about model-driven engineering. Well, a structural model actually, as we said in the first in the introduction, structural model of software display the organization of a system in terms of the component. What's really the contents of it? What are the components of it? Like, you know, in the system analysis and design, we talk about level 0 diagram. When we take the context diagram and then we decompose it to its component, which it is make up that system, and what is the relation between it? What is the relation between the components? In the class diagram, we'll show these, the classes or the object and the relation between. Structural model may be a static model, which show the structure of the system design, or dynamic, which show the organization of the system when it is executing, the relation between them. Who's gonna call what? Who has an impact of which component has impact on the other one. We create structural model of a system when you are discussing and designing the system architecture. What is a class diagram? Class diagram in software engineering, in the unified modeling language, it's a type of static structure diagram that describe the structure of a system by showing its classes. What's really the object of that system? Their attributes, what the attributes of each class, the operation, what is the function and or method it's done in that class, and the relation among these objects. It is a blueprint. It is a class diagram, whatever, it's a blueprint that used to create object. The class defined what object can do. Class diagrams are used when developing the object-oriented system model to show the classes. As we said, just it is the object, or they are the object of the system, and what really the association between them. شو العلاقة between these classes or these objects. An object class can be thought as of a general definition of one kind of a system object. So it is general definition. It's like a patient. And instead of patient, it's like a person. It's like a vehicle. An object class can be thought as a general definition of one kind of a system object. The association is a link between classes that indicate that there is some relation between these objects. When you are developing model during the early stage of the software engineering process, objects represent something in the real world, such as patient, prescription, doctor. And this one to talk about object. That's why they're saying, it is easy, to develop an object-oriented programming, whatever, when you go to the hospital. An example, you want to really have a hospital system. Look at the object around you. You see a doctor, you see a nurse, you see a prescription, you see a lab, you see operation room. All these are objects of that system. Okay, let's look at the UML classes and association. The association, actually, it is a relationship between two classes, like a patient and the patient record, like a student, a college. And what is the relation here between the student and the college? It is studies. When you talk about, we're saying studies, student studies in a college. Patient has a patient record. So association here, it is has. The kind of relation represents a static relation between classes A and B. For example, an employee works in an organization. Employee works in organization. What is the relation between the employee and the organization? It is one to many. There are many employees work in the same organization. If we allowed the employee to work in many organizations, we could really say it's many to many. Many employees work in many organizations. In this example, the relationship between a student and college is shown, which is studies, as we said. Student studies in a college. Patient has the relation between the patient record. Patient has a patient record. Okay, what's multiplicity? Multiplicity is active logical association, when the cardinality of a class in relation to another is being depicted. For example, let's talk about an example. For an airline company. For an airline company, the fleet of planes, one fleet may include multiple airplanes, while one commercial airplane may contain a zero to many passengers. Multiplicity specifies whether the association is mandatory or not. It has some lower bound and upper bound. It's like in our example here, student, we said the association, it is studies. Student studies in a college. Now the relation is like one to many. There is one college and it has many students. If we look at this example for the mental health care patient management system, the classes and association. If we look at the classes in that system, it's like consultant is a class, patient, condition, general practitioner, medication, treatment, hospital doctor, consultation, whatever. And then we have to set up what's the relation between these. It's like example, if we take, patient referred by general practitioner, like a consultant and patient. Consultant, patient referred to a consultant. What is the relation between these? What's the multiplicity? Well, how many we have? We talk about consultant and patient. The consultant has many patients. So we see one in the consultant and one ... star in the patient. This means it could have one consultant doctor has many patients. If we look at the consultation class, how really we form it, how we really structure it. We put the name of the class at the top, consultation. We put the attributes used by this class, like doctor, date, time, clinic, reason, medication prescribed, treatment prescribed, voice, etc. And then at the bottom, the lower part, are the function. The function, the method it's used by that class, like new, prescribe, record note, transcribe, etc. Okay, let's talk about generalization and association. Generalization is an everyday technique that we use to manage complexity. When there is something complex and detailed, whatever, probably we could generalize. They tell you here, rather than learn the detailed characteristic of every entity that we experience, we place these entities in more general classes, like animal, cars, houses, etc., and learn the characteristic of these classes. Well, this allows us to infer that different members of these classes have some common characteristic. This means that the upper class, the superclass, has some characteristic. The lower class, it has all these characteristics plus more. Like we're saying squirrels and rats are rodent. Rodent, here it comes as قوارض. But rodents are animals also. So the description of animals, the attribute of animals, it goes to the rodent. And then the description or the attributes of animals and rodent, it goes down to the level below, which is squirrel or rats. We'll say in a modeling system, it is often used to examine the classes in a system to see if there is a scope for generalization. So we look at the classes, and if we see if there is a commonality, if there is a common things between these classes, we put it in the upper class, because we don't want to repeat the same attribute, the same functionality in each of these classes. If changes are proposed, then you do not have to look at all classes in the system to see if they are affected by the change. So why we have generalization? Because if we have common things between some classes, we put these common things in the upper class. And then by the inheritance, with the lower class inherit all these attribute and functionality of the upper class, which it is the parent class. In case if we're gonna change, modify the program later on, whatever, and we go and we change that specific class instead of changing all classes beneath it. In object-oriented language such as Java, generalization is implemented using the class inheritance mechanism built into the language, as we said earlier. In generalization, the attribute and operation associated with the higher class, the parent class or classes, are also associated with the lower classes. The lower classes are, we call them subclasses or derived classes or child class, inherit the attribute and operation from their superclass, base class, the parent class. These lower classes then add more specific attribute to its operation and operation to it. So if the lower class it needs more logic, more detail, more attribute, it will be added to them, but not to the superclass. If we look at this example, generalization hierarchy for doctors, doctor in a hospital, all the doctors there in the hospital, we call them doctor. But the doctor, it could be a hospital doctor or general practitioner. The hospital doctor, it could be a consultant or a team doctor. The team doctor, look, those in team, it could be a qualified doctor or a trainee doctor, like the student, the doctor, those, trainee, المتدربين, or a qualified doctor, a doctor who just finished, the qualification of his degree. And that's why, you see, if you look at the doctor at the top, it has some attribute and functionality. The general practitioner, it has the same. So they inherit those attributes from the doctor above, and if it has some detail information related to the general practitioner, you could add it to that class. So in case if we're gonna change, if there is a change to one of these classes, we'll go to that class like a doctor and change it, and the change will be taken in all these lower classes. Well, if you look at this, generalization hierarchy with added detail, like a doctor. A doctor, it has a name, it has a phone, and it has an email. Those attribute. The functionality or the method, register and deregister. If you go to the general practitioner, it has a practice and address. But actually, it inherits what really in the doctor. So general practitioner had a name and the phone and email and the method or the functionality doing register and deregister. The same for the hospital doctor. It has all the information in the doctor inheritance. And it has more attribute, probably a staff number, one pager number. Okay, about aggregation. Aggregation is a special type of association which objects are assembled or configured together to create a more complex object. Like what? If we look at company, the company has many departments. Department class can have an aggregation relationship with a company class. We have a company and department, which indicate that the department is part of that company. An aggregation model shows how classes that are collection are composed of other classes. Aggregation models are similar to the part of, as we just said earlier, that department is part of the relation. Aggregation indicate a relationship where the child can exist separately from their parent class. Example, automobile is the parent and car is a child. So if you delete an automobile, the child car still exists. So the car is really part of our relation, let's see. It's not really part. It is related to the automobile, but the car could exist by itself. Again here, aggregation is a special type of association that models a whole part relationship between aggregate and its part. The aggregate, the parent, and the children. For example, the class college is made up of one or more students. In aggregation, the contained classes are never totally dependent on the life cycle of the container. Here, the college class will remain even if the student is not available. The college class, it will stay and remain. The college, it's not gonna go away if there is no student enrolled this semester. Well, for this example, if you look at the aggregation association for the patient record, consultation and patient. You have a patient record, it has a consultation and a patient. The patient record, it has a patient information and the consultation. So it is part of. The consultation is part of the patient record. The patient record contains both the patient information, whatever, and the consultation. Okay, composition association. Composition is a special type of aggregation which denote a strong ownership between two classes when one class is a part of another class. For example, if a college composed of classes student, college and student, the college could contain many students, while each student belonged to only one college. Composition display relationship where the child will never exist independent of the parent. Example, house is a parent class and room is a child. Room will never separate into a house. This means you cannot have a room without having a house. The composition is a special type of aggregation which denote strong ownership between two classes when one class is a part of another class. As we said now, if the college is composed to a class student, the college could contain many students, while each student belongs to only one college. So if a college is not functioning, all the students also are removed. Finally, this is an example of a class diagram for the ATM. It has around 7 classes and the relation between them, and you could really look at it and study it and see how really this relation, one-to-one, many-to-many, etc. By this time we finish this lecture, which should cover just the class diagram, and we go for the last diagram, which it is the behavioral diagram, in the next lecture.